Welcome to today's explainer. Today we're taking something that a lot of us probably remember as a super frustrating classroom chore, and we are going to completely transform how you see it. We're going to reveal how this subject is actually a powerful, real-world decoder ring that helps us make sense of the entire universe. I'm talking, of course, about algebra. Okay, let's dive into this. Here is our quick roadmap for today. First up, unlocking the mystery. Second, algebra in everyday life. Third, core concepts in action. And finally, the gateway to excellence.
All right, kicking things off with Section 1, Unlocking the Mystery.
To really grasp what algebra is all about, I want you to imagine, just for a second, that you're playing a high-stakes mystery game. In this game, crucial pieces of information are hidden away inside these locked boxes. You have absolutely no idea what's inside them yet. But here's the clever trick. You can actually deduce what's inside simply by observing how those boxes relate to the things around them. You don't even need the key if you can just understand the environment.
And really, that brings us to the truest definition of algebra. It's essentially the art of using symbols. You can think of them as nicknames for those unknown locked boxes. So instead of just stating a static fact like, 2 plus 3 equals 5, algebra lets us say, if I have some unknown amount of money in a box and I add $2, I'll have $5. By assigning a simple letter to that unknown box, we can organize our thoughts and keep the whole equation perfectly balanced. Whatever you do to one side, you literally just do to the other. It's this beautiful system of pure logic that helps us find shortcuts to incredibly complex problems.
So, the absolute crucial point here is understanding the difference between arithmetic and algebra. Arithmetic is fixed. It's kind of like drawing a picture of a single specific tree. It only describes that one tree. But algebra, well, because of its use of symbols, it's a flexible blueprint that can describe how any tree grows under literally any changing situation.
Moving right along to Section 2, Algebra in Everyday Life.
Now, I know what you might be thinking, but algebra is absolutely not just for the classroom. It's a mental tool we use constantly, every single day, often completely on autopilot. Let me prove it to you. Take the number 1.5. A lot of us have a 1.5 gigabyte daily mobile data limit, right? If you decide to watch a streaming video that eats up, say, 500 megabytes per hour, you instinctively start calculating how many hours you can watch before your data runs out or your speeds get throttled. Guess what? Figuring out how long your 1.5 gigs will last at that specific rate is pure algebra. You're solving for an unknown variable without even realizing it.
Or how about this? A $120 restaurant bill. You're out with a group of friends, it's time to split the check, but wait, one friend ordered that extra, highly expensive dessert. We've all been there. You can't just divide the bill evenly anymore. You actually have to subtract the dessert, divide the remainder by the number of people, and then thoughtfully add that dessert cost back onto your friend's share. That mental gymnastics you just did, that is algebraic logic saving your wallet. We honestly do this all day long. Think about grocery budgeting, figuring out exactly how many $4 bags of flour you can get with a $20 bill. What about travel time? Estimating when you need to leave the house if your destination is 10 kilometers away and traffic is crawling at 20 kilometers per hour. Fitness tracking, calculating the gap between your 500-calorie burn goal and the 320 you've already hit. Or cooking, scaling a recipe meant for 4 people up to 10 people means you're multiplying all your ingredients by a factor of 2.5. Even home decorating, like calculating exactly how many 12 by 12-inch tiles you're going to need for a bathroom floor. Whether it's managing a salary commission or figuring out the required run rate in a cricket match, you are already an everyday algebra master.
Let's jump into Section 3, Core Concepts in Action. Now that we've totally established you're already using it, let's break down 5 specific, formal rules of this decoder ring and see exactly what they look like in the real world. Rule number 1, variables and constants. A constant has a fixed value, like the number 5. It never, ever changes. A variable, on the other hand, is a symbol, usually X or Y, that represents a value that can change depending on the situation.
You see this instantly when you hop into a taxi. The meter usually has a base fare just for getting in the car. That base fare stays the same no matter what, so that is your constant. But then there's a charge per kilometer. Because the distance you travel changes, that is your variable. So the total cost of your ride is super simple. Cost equals the rate times distance plus that base fare.
Let's look at Rule 2, linear equations in one variable. By formal definition, this is just an equation where the highest power of the variable is 1. No squares or cubes here. It's usually written in the form ax plus b equals 0. And this brilliantly illustrates our next real-world observation, filling a water tank. Let's say a tank already has 10 liters in it.
A top is turned on, adding 2 liters every single minute. You want to know exactly how long it'll take to reach 50 liters. Well, you are actually setting up a linear equation. 2 times the time plus the 10 original liters equals 50. You solve for time, and boom, you've just done linear algebra.
Next up is Rule 3. And yeah, it's the one that sounds a bit intimidating. Quadratic equations. This is an equation in the form ax squared plus bx plus c equals 0. The variable is actually squared here. But seriously, don't let the name scare you, because I guarantee you've seen this in action countless times.
Just think about playing basketball. When you throw a ball toward the hoop, it obviously doesn't travel in a straight line, right? It arcs in a shape called a parabola. The height of that ball at any given second is dictated by gravity, its initial speed, and the height of your release. That complex curving path is perfectly described by a quadratic equation. And get this, engineers use this exact same quadratic formula to calculate where a rocket will land or the peak height of a suspension bridge. Moving to Rule 4, Arithmetic Progressions. Put simply, this is a sequence of numbers where the difference between consecutive terms is completely constant. In math speak, we call that constant difference D.
Let's see how this actually builds a physical space, like auditorium seating. Picture your favorite movie theater or a school auditorium. The first row might have 20 seats. The second row has 22 seats. The third has 24. They're adding exactly 2 seats per row. That tiered seating layout doesn't just happen by accident. It's strictly dictated by this arithmetic progression, which allows architects to calculate exactly how many seats will fit in the 50th row without having to draw every single one out.
Finally, Rule 5, ratio and proportion. A ratio just compares 2 quantities. A proportion simply states that 2 of those ratios are perfectly equal to each other.
The absolute classic example of this is map reading. When you look at a map for a road trip, the legend might tell you that 1 centimeter on the paper represents 50 kilometers in reality. That is a constant ratio. So when you measure a 4-centimeter gap between 2 cities on the page, you instinctively use proportion to instantly know you've got a 200-kilometer drive ahead of you.
And that brings us to our final section, the gateway to excellence.
So we've seen how these concepts govern our daily, totally normal tasks. But mastering these micro, everyday concepts is actually the key to unlocking massive, macro life goals. Algebra is truly the hidden language powering our modern world. It is the primary tool for modeling physical reality. It's used in medicine to calculate precise, life-saving drug dosages based on a patient's exact body weight, literally a matter of life and death. It's the structural logic underneath every single smartphone app you use. And of course, in engineering and space exploration, it turns incredibly messy, complex variables into solvable, predictable structures.
And for any students listening to this explainer right now, especially those of you facing down highly competitive entrance exams like the IIT JEE, NEET, BITSAT, IISER, or NEST, listen closely. Algebra isn't just a subject on the test. It is the absolute foundation of the mathematics and physics sections. You won't just be solving simple linear equations. You're going to be dealing with complex numbers, matrices, and permutations. But here is the secret. Mastering algebra gives you the ability to manipulate variables with incredible speed and accuracy. And that speed and accuracy, that is the exact X factor you need to clear the notoriously high cutoffs of these national-level exams.
By building a really strong algebraic foundation, you aren't just learning rules from a dusty textbook. You are equipping yourself with supreme analytical firepower. You literally have the blueprint of reality right at your fingertips. So, as we wrap up today's explainer, I'll leave you with this one thought. Now that you finally hold the decoder ring, how will you use this analytical firepower to decode your own future? Thanks for joining me today, and keep exploring.